All right, let's take a look at the idea of finite and infinite decimals. All right, we've been converting fractions to decimals, and when we do that, we sometimes come up with a nice, neat ending or terminating decimal, and sometimes we come up with a repeating decimal. Well, those are the two definitions of finite and infinite. A finite decimal is one that ends or terminates. All right? An infinite decimal is one that has a repeating pattern to it. That would be an infinite decimal. So as we're doing our conversions, we're going to need to see which one of these two things is happening. By the way, finite and infinite decimals are all rational numbers, okay? Because if you can express a number as a fraction, then it's rational, all right? Those are rational numbers. Terminating decimals are rational. Repeating pattern decimals are rational, which means finite decimals are rational and infinite decimals are rational. So let's do a couple. Is 5/8 finite or infinite when you convert it to a decimal? Well, let's do the conversion then. Let's do the 8 doesn't go into 5, but it does go into 50. 8 times 6 is 48. Subtract and get 2. 8 times 2 is 16. Subtract and get 4. 8 times 5 is 40. I got no remainder. This is finite. All right? I divided and it came out to a nice neat 0.625. That is a finite decimal. All right? Is 2/9 finite or infinite when changed to a decimal? Well, put the 2 in there, put the 9 out here. 9 doesn't go into 2, but 9 does go into 20. 9 times 2 is 18. Let's subtract, drop a 0. 9 goes in there twice. That's 18. I don't think it's going to change, folks. It's going to be a 2, and then a 2, and then a 2, and then a 2. So that's 0.2 repeating. Is it finite or is it infinite? Well, it's infinite because it is a repeating decimal. All right? An infinite decimal. Okay? So that's basically what it boils down to. If you can divide and you can see what you get, then you can determine whether you've got a finite or an infinite decimal. There is a little shortcut, I guess you could say, or if nothing else, it would save you from doing the long division, and it involves using the prime factorization of a number, all right, specifically of the denominator, all right? So here's a fraction. It's a little bit bigger, 9/60ths. And of course, the first thing you should always do if you're given a fraction is to simplify it. As I look at this, I'm pretty sure that both of these numbers are divisible by 3. So 9 divided by 3 is going to be 3. 60 divided by 3 is going to be 20. And now I'm going to do a prime factorization. Well, I don't have to do anything with the 3 because it's done. But let's break down 20. Well, 20 is 4 times 5. That's prime. However, this isn't. So the prime factorization of 20 is 2 times 2 times 5. Okay. Now, here's the rule. If you do the prime factorization and there are only 2's and 5's, okay? If there are only 2's and 5's in the denominator, all right, I can guarantee you that you got yourself a finite decimal. Why? Well, if there are only 2's and 5's down here, then I could introduce or change that fraction to make it have a denominator of 100 or 10 or 1,000. And anytime you get one of these numbers as a denominator, how easy is it to change it to a decimal? It's a piece of cake, and it's going to end. Whatever number is up here, that's what you're going to end up with. And so this, so this is 3, over 20. I guess what I'm saying is if you can change that to 100, which all I got to do is multiply by 5, that's 15. That's 15 hundredths. That's 0.15. So you can do it by looking at the prime factorization and knowing whether or not, it may not exactly do it for you, but at least you can figure out whether you're going to wind up finite or wind up infinite. All right? Hope that's helpful to you. Good luck.